Okay, so last time I think we were looking at the data types, and we started looking at data types. And so, any questions? Okay, fine. Just quick overview of what we did last time. So last time we had seen about data types are categorized mainly into two types, right? There will be primitive types and we have the primitive types and the built-in, or we call them as the built-in types and the reference types, right? So we have data types being primitive data types or built-in types, or the other one is the reference types. In the primitive types, yes, we can say numeric and Boolean. Okay, numeric and Boolean. And within the numeric type, you can say, okay, we have the integral types, okay, and floating point types. And so that's just nothing but further categorization of the data types. Okay. And then, yes, if we say integral types, then these are the signed data types. Right? When they are signed, the ranges are from minus to positive. Most significant bit becomes the signed bit. Right? If it is 1, it's a negative number. Okay. And it follows the 2's complement here. Right? So integral types, byte, short, int, long. The sizes of each of the types is fixed, right? Because it's for a specific platform called Java, right? For C language, if you know, the size of the int would depend on what is the platform, right? You have a 32-bit platform, the size will be 32-bit. It's like that. Okay. So size of int, yes, for Java it is fixed. Okay. Fine. And then the char type is this. Fine. The size is 2 bytes. We understand why it is 2 bytes. Okay. For the integral types, yes, we had division by 0 also, right? We checked division by 0. For integral types, it's a error at runtime, right? It's an error, right? Okay. So if you divide one integer, so it's an integer division by 0, it's an error. Whereas for floating point types, fine, we had seen this. Yeah. For floating point types, yes, here is where we have seen that, yes, we can get infinity, right? A positive infinity, negative infinity, and not a number. 3 kinds of values were there. Fine. And okay. Fine. And then I think we went for the literals. Yeah. So fine, literals, the constant values, fine, which we can write. We can write for reference type, it is true, false. Okay. So not reference. For Boolean type, it is true, false. Fine. There are two literals for Boolean, true and false. There are literals for, as far as the literals for the numeric types are concerned, integral type especially, you can specify them in either binary, octal, decimal, or hexadecimal. And whatever way you have values, because sometimes maybe you are working with at bit levels and therefore you might be having bits. So you want to specify in binary, yes, you can say 0b and write the binary digits. Right? Also, for the purpose of grouping, we can use that underscore thing. Okay, so even that can be done with binary. Okay, so for example, yes, I could be writing binary something like this, 0b, sorry, b, and then I'll say, okay, 1011 underscore 0101, because grouping with 4 is a good idea, right? Something like this. So this is also valid. Okay. You could be doing it with whatever 0b, that start part is just for indicating that next is all binary. It's all binary. I'm giving in binary the constant value. And for readability, yes, you are grouping in 4 bits. So you are using that underscore for grouping purpose. Okay. Right? So many times, yes, you may be working on things which require to go at the bit level also, right? So there, yes, this might be useful. Okay, fine. And then we came to the char type, right? Character constants, yes, we have \r, \n, \t, \f for form feed, \b for bell. Okay. Okay, this was all about the character sets we have. Okay, so various characters sets are available, but what Java follows is Unicode. Okay, and the range for Unicode is from 0 to, in hexadecimal, if we specify, it is 0 to 10FFFF. Okay, and this is the range. But you find that char, the size is 2 bytes, but the range is bigger than what can be accommodated in 2 bytes. Yeah. So how does it manage? Okay. Then that's a fine. You will have a question like this, no? If the range is bigger, right? Hex. What is the range for uh, 2 byte value? Right? We have seen that range for. Okay, range for char. Let's say range for char is. I'll write in hex. Okay. So the question is, oh, how do we represent this then? Okay. So one thing here, a single char value is not sufficient to represent all the Unicode characters. Okay. Yeah. Okay. Fine. So fine. Let's see. So how this works, right? Let's check that. Okay. Okay. Let me copy this in today's date. Okay. Fine. So coming to this, right? Range for char is 0 to FFFF, whereas range for Unicode is from 00000 up to. See, it's good to be always familiar with the hexadecimal system. Okay. Fine. For programmers, I'll say they should know hex. Okay. Should be familiar with hex. If we talk about hex, yes, it should be like hex should be native to a programmer. Let's say. Okay.
Like, does it help in like identifying problem?
Yeah, many problems. Not identifying, I'll say, but there will be problems where you will require to be knowing hex. It's always good to be knowing it. It's actually quite simple because hex to binary is very simple because it's a group of 4 bits. So every 4 bit, if I take 4 bits, how many combinations do I get? How many different combinations with 4 bits? 4 bits, 16. 2 to the power. Right? Each position we have 2 possibilities, right? See, it's okay. A very quick look at hex and binary if you want, right? So, what are the digits for hex?
0.
After that, right? And look at the binary digits for each of them. Okay, these are the bits. Okay. The places where 2, 4, they are quite simple to remember, right? 2, 4, 8. And this should be almost all as a memorized almost. Right? May not have memorized everything, but from one you can easily derive. If you know one, you can derive their neighbors, right? So that way it is quite simple. I'll show you. Okay. Okay. See, powers of 2, fine. There'll be always 1 and followed by. Okay, 2 to the power of 3 is 8. Okay, so 3 zeros. That way. Okay, fine. So A is 10, right? And we say 1, 0, 1, 0. So, fine. So that way it's quite simple. Okay, and then it's a neighbor, right? So you should be able to know that. That's all. Yeah, and C is 1100. So remember, just a few of them. The numbers can be easily derived. And that would be 1111. So fine. So that way, from binary and hex, the relationship is very straightforward. Okay. So anyone working with bits, fine, we won't be afraid of looking at bits now. The hex and binary. And we normally would use hex because it's much shorter rather than writing long set of bits. So hex is something which is most commonly used. Okay. Fine. And then I think we were looking at this range. So if you are familiar with hex, then the next thing to be understood is, okay, how this is covered, how this range is covered by using char values. And there is actually a system, because this is a char type, right? It's and the char type is nothing but we say, oh, we want to represent Unicode character values. Unicode character values have this range. Fine. How is it covered by using this? Okay. So we have something called encoding. And we need to encode the value, right? It's just, look at it, it's a numeric value in that range. Okay. And even how do we remember that what's the size? What's the size? How many values are possible in this? It's 17 multiplied by 65536. Okay. What is that 65536? Power of 16. Right? Power of 16 is a single char, right? See, this is one range. If you look at this range, the char range is this. And that is multiplied by 17, and that's the range for this Unicode characters. Okay, and easier way to remember this if you want. Okay, actually, the Unicode characters, we say it is divided into 17 layers. These are the 17 layers. And which are those 17 layers? So if you are looking at that range, fine, I'll just put it here. So, fine. So the first range is rather than it's a plane. We call it as a plane. Okay. So there are 17 planes. The first plane is 0, 0. The second plane is 0, 1. What is on the other side? Up to Okay, so fine, the first two bits, first two hex digits, not bits, first two hex digits will remain 0 1. So that's a plain number 0, that's a plain number 1. Like this, you have plain number 2 and so on, right? And we'll go right up to, okay, let me put the intermediate thing, 0 9. What's the next one? 0 8. Okay, fine. And so on. Okay, and it goes right up to 1 0, right? See, you'll so the one fine. So this is going from 0 up to 16, including of 0. So that's total of 17. And 17 planes for the Unicode characters. Each plane is 16 bit. Okay, this is one thing you can see. Okay, now another thing, why, how we can, and so we, because this is a value which is slightly odd, right? 21 bit we say. It's using 21 bits if you look at it carefully. 444 bits. So this is 20, and here it's only 1 bit which is used. Fine, 0 or 1. Fine, those two possibilities. So that way it is 21 bits. Okay, but less than 21 because it's not covering all the values. It's not one FFF. So that would have been full 21 bit. It's less than 21 bit, but more than 20 bits. Okay, so then how does it? How can this value be represented? Fine. So this is a numerical value, but then we say, oh, we need to encode this value. There are different kinds of ways of encoding. So there are encodings, and you would have come across these terms. Okay, normally you should have come. Okay, the names of the encodings which I'm now going to write. Okay, okay, let me put it here. So we have terms like encoding name is UTF-8. This is the most commonly used one. Okay, but what Java, the care of Java is not UTF-8. The care of Java is a UTF-16 encoding. Okay, what is that 8 and what is that 16? Well, that way, someone even have there is a standard called UTF-32 also. Okay. Fine. But anyway, that need not be used. So it's like your char value, which is in this range, to be represented, I would like to use 8-bit units. Fine. My unit of encoding will be 8-bit. I use one or more such 8-bit values to represent a value in that range. The Unicode value, and it has a bigger range, right? 17 into 65536. Okay, to represent that value, if it is, if I'm saying, oh, I'm following UTF-8, I would encode into 8-bit values. For one character, it may take more than one unit. My unit of encoding is 8-bit. I deal in 8 bits. Okay, someone says, no, I'll deal with 16 bits at a time. Okay, and that's where we have a UTF-16 encoding. So the care of Java is actually not Unicode, but it is UTF-16 encoded value. And it is UTF-16 encoded value. Okay, and because it's fine, and we'll see what is UTF-16. Fine, we can quickly understand how UTF-16 has been designed. Okay, and so if you want, if you have the numerical value in that range, how do we encode to make it 16-bit all the time? Or so see, what happens is any value in this range can be represented in single 16-bit unit or two 16-bit units. It's either one 16-bit value, or sometimes there are values which will require two 16-bit values. Okay, 2 units we say. Fine. And I'll also put all the terms which are needed. And see, you should be knowing these things, and that's one thing. If you are dealing with text type encodings, yes, character encoding, text in Java, yes, you should be familiar with UTF-16 at least. Okay, so what is UTF-16? We may try to understand how UTF-16 is designed. So if you have to encode, fine. So how now one important thing about Unicode itself. Okay, see, not every character position in Unicode has been encoded or given a character, right? We don't have characters at each and every location in this. Okay, there are a lot of gaps, and there is a gap which has been left. There is a portion which has been left knowingly. Fine, it has been kept reserved. Okay, and I'll tell you what that range is. So there is a range. Okay, 0 D 80 0 T 002. Okay, we'll confirm the exact range because when we look at the way it is done, D800, sorry, 0D, okay, D800 to DFFF. Okay. This is a range which is reserved, fine, in Unicode. Okay, if I have to put 6 hex digits, yes, I'll put it in the beginning here. So this is the range, it's reserved. Fine. For what we call as surrogate pairs. The range in this, the range from 00D800 to 00DBFF, half the thing, okay, is we call as high surrogate, and okay, the other half is the low surrogate. Those values we say they are the low surrogate. And we actually so when we encode a value in the range, okay, so if value is to be encoded in UTF-16, okay, okay, so if we talk of UTF-16 encoding, then value in the range okay, fine. So if we look at this range, of course that range is not a valid character, right? So we shouldn't be getting values in that range for encoding purpose, okay, and because it's a reserved area, it's not for any character. So if you are encoding characters, you won't have that range, okay, and therefore the value in this range is encoded as it is. So requiring only 16 bit, whatever the value is, that's the encoded value for UTF-16. Okay. So for the values in the range, okay, so what's the range now? 01, 000 to 10FFFF, right? For the values in this range, okay, encoded into 2 units. Okay, so this value gets encoded into 2 units. And what are those units? So let's see how this units are decided and how the whole thing works here. Okay, so if a value in the 16-bit range, then that's a 16-bit range, first one. We don't require 2 units. Right? 1 char is sufficient. Okay, whereas in case it's in this range, okay, it will be encoded into 2 units. The first unit is the high surrogate, it will be in the high surrogate range, and second unit in the low surrogate range. And if you want to know exactly how it is done, okay, so if we assume we have a value x, let's say x is a value in the range, okay, that's a range, right? Okay, so what is being done? If x is the value in this range, okay, then subtract, okay, from x, subtract, okay. Fine. So if you subtract, what's the range now? What's the value range for the new value? What is being done basically is you are shifting one layer up. Fine. That's the starting point of the second layer, right? So one layer up, right? So what does it become? 16 layers? Okay. Shift the value to one layer up. Okay. So you will get now 20 bits. So this becomes a 20-bit value now. Fine. So from this, fine. So the value, fine. So this, okay. Okay. What's the range now? Okay. I'll now use only 5 bits, 5 hex digits. It's a 20-bit range. Fine. We have brought it from 21 bits, something more than 20 bits rather, fine. It was one layer up more, right, to 20-bit value by deducting that. Okay. Now what we do is, so we got bits, fine, from 0 to 19, sorry, or most significant bit we say bit 19 up to bit 0. And bit 19 to bit 0, it's something like this. Sorry. Anyway, so here, let's see. Right? So first was we shifted by 1 unit, it's a 20-bit value. So this is my bit position 19 and this is my bit position 0. Fine, this is what we have. Now, so this is total of how many bits? 20 bits. Okay, break it into 2. Okay. So we have bits from 19 to 10 and from 9 to 0. Okay, these are the two parts we have broken into 10 bits. And what we do is, so what we do with the first bit is, now how high surrogate will be derived? It is nothing but you have 1 1 0 1 1 0 as the first 6 bits, and then these bits which you have, they will follow here. Okay, so it is then followed by whatever bits you have from 19 to 10, they will come here. The second unit will be defined as 1 1 0 1 1 1, first 6 bits, and then the other 10 bits are the lower 10 bits, they will be here, and so they'll be taken up here. Okay, so you got your bits from 9 to 0 here. Okay, now Look at that, how it matches that range. And we said high surrogate, we know the range, D800. Okay, how do we derive that? So what's the possible range here? All zeros to all ones. If it is all zeros, the lowest value for high surrogate is, so I have to group into 4 bits, right? 1101, what's that? D. 1101 is D. D, 10 and all zeros. So 1 followed by 3 zeros. That's 8 and all zeros. So 0, 0, right? And this goes, if I have all ones here, first 4 bits is D. Okay, then it is 1011, right? Everything is 1, 1011. What's 1011? 1010 was 10. A. So this is B. So DB, FF, all ones. High surrogate. And range for high surrogate. And range for the second one. So this is 1101. That's again D. Right? If it has all zeros here, right? If it is all zeros in the bits from 9 to 0, right? 1100 is C. 0, 0, going up to D, and everything is 1. So that would be F, F, F. Range for low surrogate. Right? So values in the range from 0 to, fine. How this is what we call as UTF-16 encoding, basically. Okay. See, when you save a text file, and in many of those editors, you will get this option of saving into according to which particular character set. And it will have option for saving as, if you try to change the encoding, yes, you can specify the encoding as UTF-16 also, UTF-8. And of course, there's something more. Okay. Yeah, good. It reminds me that there is something called byte ordering. Are you aware of the byte ordering? Okay, so because this it does matter, byte ordering matters, especially with communication, wherever there's communication, even in that also byte ordering would matter. So I'll just introduce what is byte order, what we mean by byte ordering. Okay. Yeah. So what is byte ordering? There are 2 kinds of byte orderings. Okay, we call as big endian and little endian. Okay, let me ask you a few things here. Okay, in the 2 byte orderings which we have, okay, byte ordering is, we have 2 names here. It's a big endian and little endian. Okay. See, what we normally use, this is dependent on the machine architecture. Okay, we are following the Intel series, right? Intel and Intel compatible things. Okay, so we say x86, x64 or whatever, right? So they all are following little endian byte ordering. Okay, whereas if you switch to a machine, like someone says, oh, let's use the Raspberry Pi, right? Or your mobile device, right? The processor there, they follow the big endian. Right? A mainframe machine, they are all following big endian, except for this Intel series. Rest of them, most of the time you will find they will be following the big endian. Okay, Let me explain like this. Let's say we have a value 75. Okay, we have the value 75 to be stored in a int. What's the size of int? 4 bytes. Okay, so you got 4 bytes. Okay, so there is some location in the memory. Okay, so we have some location in memory where we have, okay, so where we are, so let's say this is memory, just byte by byte, like, okay, at byte level. So memory has addresses, there's the location. So let's say, let me give the location name as 1000. Okay, so at location 1000, okay, I am storing 4 bytes for storing the value 75. Fine, value is 75 and we have to store at location 1000 and I should be occupying 4 bytes here, right? So we understand 75 is easily accommodated in only 1 byte. Right? So, if you have that value, how do we write a value? 00000075. And it should be written as 00000075. Okay, so yeah, at 1000 I should be having a 00, 1001, 00, fine, again 00, and here will be my bits which are non-zero. Right? 1 byte contains the value 75, others will be containing all zeros only. So tell me, is it going to be like this, or is it going to be the other way around? When one system says, oh, we'll have 00 here, 00 here, 00 here, and here 75, if I have to specify in hex, 75 in hex, okay, 16 into 3 is 48, 4 is 4 is going to be 64. Okay, 64 and 75, what's the difference? 9. Fine, so this is 5 9 11. So that would be B, right? So it's okay. So this will be 5B, I think, right? No, 4B. Sorry, this is 4B. Okay, so this is what we call as big endian. If this is the ordering followed, then this is what is big endian. But if you have Intel machines, okay, fine. If you have Intel machines, fine, at that same location, how it would have worked is something like this. I'm storing at 1000. What am I storing? The value 75, or it is 4B in hex, right? It has to occupy 4 bytes, and how will it be occupying those 4 bytes? The first byte will be 4B. Okay, there's a logic behind this also. And then the next byte will be 00. That's how it will be. Okay, so even when you are writing into a file, if you are writing some binary data into a file, it's important to know what ordering are we following. Are we following the big endian or little endian? See, ordering matters. Wherever any data type which requires more than 1 byte, we need to know what is the byte ordering. Okay, fine. The processors at their end, yes, Intel and all Intel compatible, they follow what we call as the little endian. Oh, what is little endian? Which is the least significant byte here? Least significant byte in that value, which has the value 4B. That's the least significant byte for me. Other bytes are, most significant byte is zeros. This is least significant byte at lower location. Their logic is like this. Okay. Yeah. So any Intel processor, it works in this manner. Right? If you're using a C program, and you're writing C language, right? And you say, oh, let me store this int value, maybe int is 64-bit, 32-bit there, okay? And if you write that from C into a file, and you try to read it from Java, oh, what is Java? Java is a platform. It's a machine, virtual machine. It's a non-Intel machine. Okay, so what is the ordering? Big endian. Okay. So while dealing with binary data, yes, we'll have to be careful about it. We need to be knowing about the byte ordering. See, it is also in communication, right? From one end, the sender is sending some binary data, the receiver is receiving the binary data. They both have to know what is the byte ordering. I have to send in this order, or I'm receiving in this order. Okay. What is the byte ordering followed is important to know. Okay, fine. And this is needed where we have more than 1 byte. Fine. If it's a 1 byte data, okay, fine. Your type requires only 1 byte, it's fine. But if your type needs more than 1 byte, byte ordering matters. Okay, and these are the two names given to them: big endian, little endian.
Does it make any difference if the like one is sending in, let's say, little Indian and other is
Yeah, he'll be misinterpreting it.
the data will be like output?
Yeah, yeah, it will be completely different. I sent this, no, you sent this. The understanding has to be proper. Right? So when we talk of I was talking about that UTF-16 encoding, right? So when we look at that UTF-16 encoding, okay, the encoding is UTF-16 encoding is again, because it's 2 byte, right? 16 bits. So each unit is 16 bit. So it needs to, you need to be telling, yes, I'm storing in UTF-16 big endian, or UTF-16 little endian. So these are the variants of UTF-16. Okay, even with UTF-8, we haven't discussed the UTF-8, but yes, with UTF-8 also it matters. Okay, whether I'm going to write my initial bytes first, or maybe it will be in the reverse order. So if you say little endian, fine. So whenever we try to save fine, when we try to save a text file, then you should be, I think, let me check with this. I haven't checked with this one, but let me check here. When I'm saving, there must be an option. It says save as, and then character encoding here. It says UTF-8. Yeah, with UTF-8 you won't have the bit. It's 1 byte and fine, 88 bits. So there you don't have big endian, little endian. UTF-16, yes, you should be having. So you want to save it as what? Okay, let's see what are the encodings available. It's not allowing other encodings, it seems. Okay, Windows has some problems. Find the, see, it's saying, right, line ending. We talked about that earlier, right? Whether it's Unix or Linux, then it will be only \n. Otherwise, yeah, Mac OS Classic or, okay, I think somehow it's not showing the full list. Let me try with the mouse. Yeah, yeah. Okay, yeah. Here you can see UTF-16, right? So when you save a text, now when it is not giving me option of big endian, little endian, it would mean whatever is the native platform. So what is my native thing here?
Windows. Intel.
Yeah, Intel. So that's going to be little endian. If it's not giving me the option of, okay. So if it doesn't give me the option, so clear, when you store any text, then you'll always have this option of specifying which text according to a particular character set. What character set I'm following. Okay. Now in Unicode, what they have done, this problem was there, right? What is the problem with before Unicode? What was the problem? Same value, how it is to be interpreted, which character set am I following, right? Now here what they have done, okay, if it's Unicode, understood it's Unicode. Now here, if I am following that UTF-16, okay, with UTF-16 encoding, again the problem still remains here is, whether this is stored using little endian or big endian, how do I know that? Okay, so sometimes, not always, not all text editors or not everywhere it may be done, every system may not follow, but there is a character called byte order mark. We call it as a BOM. Okay, so there is a character in Unicode called BOM, and it has a value. Value is FF0F, or yeah, FF0F. That's a value. It's reserved for byte order mark. What is the idea here? We say this is the byte order mark, FF0F. And the other one, F0FF, is reserved, cannot be used by anyone, not used for character. So what is the idea here? Whatever, if the one who is writing the code text, one who is saving the text, okay, so at the time of saving, if it is following the big endian or little endian, whatever he may be following, he saved the data, right? But in the very beginning, he has put the byte order mark, and we call it as a byte order mark. If he puts the byte order mark, right, the other side, the reader, when he starts reading it, if he looks at the first 2 bytes, okay, if he finds it as FF0F, he knows I have the same order as what was followed by the encoder. Okay, but if he finds F0FF, he understands immediately it's not my order, it's the other order. Okay, yeah, so that's the way it is learned. Like they have a character called byte order mark in Unicode. Okay, fine. So in Unicode has so many reserved places, right? We know for that surrogate pair, for creating surrogate pair also we have that reserved range. So there are reserved places. Okay, fine. Okay, anyway, we are not saving it here, and just to show. And what was this? Line endings also, right? So yeah, line endings. And so last time, because earlier we had discussed that to know that carriage return and line feed things are there, right? Okay, it has Linux, Mac, other, and Windows, right? So 3 things. I think Mac OS Classic should be \n. Okay, this is also \n, and this is \r/n. Carriage return and line feed both. Okay, thanks. And so char type, I think it should be fine now. What is char in Java? UTF-16 encoded value. It's UTF-16 value. It's not just a it's not the entire Unicode. So we have. So how do I represent any Unicode value now? A single char not capable of all the char values, all Unicode characters. Right? If you are writing a string, right, in double quotes, it's a sequence of char values. So if you put a high surrogate followed by a low surrogate, it represents what it's also known as a supplementary character. Anything above the zeroth plane, plane 0 up to FFFF. Fine. Anything beyond that, fine, we call them as supplementary characters. And they are known as supplementary characters. Supplementary characters will require two char values. They will be requiring two char values. Okay. So your string may have, for example, okay, let's try on JShell then, right? Let's try something on JShell. We may not get some valid characters, maybe it's, or if someone knows a character in that range, okay, and it is D801. So it is D800 onwards, right? Followed by, this is high surrogate, followed by a low surrogate, D C and something, right? DC70, just like that, right? Okay. So yeah. Region file 1. Okay. Oh, I forgot the D. Oops. Okay, fine. It shows a question mark because on Linux it will show this, right? Because it's the phone doesn't support it. Right? I'll do one thing here. Okay, I have a Linux machine. Okay, I'll connect there and then we'll try this thing. Okay. Mm-hmm. 801. Let's try JShell here, and I'll just say string s is equal to, in double quotes, backslash u d801 backslash u dc70. Let's check. Okay. Oh, here also it's unable to show that. Maybe it's not a valid thing. 80.
Console is still Windows.
No, here I have seen it does show up according to the. Say, for example, we were unable to see this, right? Recollect this 0905. Yeah, that's working here. Okay, and I want it in A85. That should be the Gujarati letter. Okay. Anyway, if we can know some valid character, right, in the Unicode range, in the supplementary characters, right, then we should be able to, and of course the font there on that machine should be also supporting it, then it is possible. Okay. Okay, so that was on the other machine. Anyway, that's on the, so let's come back to the local machine. Okay. Anyway, so this was, see, the output is becoming only single character, not two characters. Understand that? It's not two characters. I have put two Unicode values, but this is from the high surrogate and this is from the low surrogate range. High surrogate range is D8002 DBFF and DC002 DFFF. That's a low surrogate. Okay. Okay, fine. So we have done a lot about the. So byte ordering is applicable to all the data types, binary types. That means it's applicable to those things which are more than 1 byte, that means short, int, long, float, double, char. Okay, and they would be affected by, fine, so they would be affected by whether it's a big endian or little endian. How am I storing it? Anyway, so we have all the required classes where we can deal with this byte ordering also. Okay, so in Java, you are trying to read something which is in little endian, it's possible, right? And you can always, you have methods to convert, reverse the bytes. Okay, fine. So now let's proceed in the data types thing. Okay, let's see what all we did in the data types. So I think we have covered the primitive types now, right? Okay, byte, short, int, long, float, double, char, and boolean. Okay, now let's move to the reference data types. Okay, so reference types, yes, which are the reference types here? Arrays. What's the difference between the primitive types and the reference types? Okay, okay, and even there, because there's something about even related to the C++, if you are using C on C++, mainly C, right? C++, yeah. So if you find some comparisons between Java and C++, it's not only Java and C++, all object-oriented programming languages except for C++. Because I haven't come across any other language, any other object-oriented language, which does not follow the object reference model, except for C++. So we have something called the object reference model, which is followed by our all object-oriented programming languages. They follow what is known as the object reference model. So according to this object reference model, the data types, so here we are talking about the reference data types of Java. Okay, fine. When we have a data type, you declare a variable of any data type. So I'm not talking about primitives, I'm now talking about reference types. Okay, then the variable are not the objects. Fine. You have a class type, you are saying string, string is name of a class. So you declare a variable string s. What is s? It's not an object of the string. S is not the object of the string. S is a reference to an object of string. S itself is not the string. Okay. See, if I say, so let's make the comparison between the primitives and the reference here itself. So we have, if I say int a equals 5, okay. We'll have space for a, okay, and this will have the value 5. Whereas if I'm saying string s is equal to hello, you will have space for s. So that's s here. What do you think s has?
Address.
It has a reference. Then we'll not use the term address. Okay. Right? We don't have pointers in Java. Right? Okay. Right. And this will be a reference to some object, right, which has the characters hello. Yeah. S is a reference. Fine. Okay. Fine. So S is a reference to a. Fine. So difference clear. Primitives have the values. Fine. You may also call them as the value types. Okay. Actually, there are other things also known as value types, but yeah. So string has a. Sorry. Primitives have the value stored in the variable. Right? The variable has the value. The location for the variable has the value. Whereas for reference type, the variable is a reference to an object. Okay.
Like, what is, let's say, there is an object and S has a reference or let's say address में क्या difference है? I'm both the same thing.
Okay. Why I would like you to avoid using the term address. Because once we say address, and you will feel like, oh, I should be able to change the address. This is something which you can do in C++, where we use pointers. You can say, oh, I want this pointer to be a specific address, right? According to your wish, not in this object reference model. And in Java especially, I'll say, if there is a string S, right? Yes, this is an address to an object of string. So object of string is separate, right? But there was some other object, right? It's not, I can put any address into this. No, that's not possible for me. In Java, it's not possible for anyone to make S, which is declared to be a string type, refer to anything which is not a string. That's never going to be possible. It can say I'm not referring anywhere. That's one thing. We have a special value for the reference type, fine, which can be assigned to a reference type or not for primitives. The value is the literal null. Null is a literal again. Fine. Null is a literal which may be assigned to, if I say S is equal to null, so if I make S is equal to null, it should mean that you're not referring anywhere. This is null and it's not going to refer anywhere. Null means not referring anywhere. And I'm not referring to an object. That's the meaning of the literal null. Applicable only to reference types. Clear? Distinction between primitives and reference. That should be clear. Okay, so reference types are references to objects. Objects of the type. Yeah, the variable is always of a particular type. Okay, so according to that type only you can make an assignment. Many of the types assignments, if they are wrong, they can be caught at compile time itself. But sometimes, yes, even at runtime, you may be forcefully making it to, you can try to forcefully make it to refer to something which is not of that type. Then at runtime, it would result in an error. Okay, yeah, we have, for that we will have to be understanding about the super type subtype things also. Okay, before we proceed further in the reference type, yeah, this idea about super type subtype for primitives. Right? Boolean is a separate type, right? But other numeric types, they have a hierarchy. They have a hierarchy. Okay, the hierarchy goes like this. Okay, so super type subtypes. Okay, and what are the super type and subtype? So hierarchy goes like this. So it's only related to the numeric types, right? Boolean is separate. So numeric types, double is a super type for all other numeric types. Right? If it's a super type, a subtype can be assigned, right? Assignment will work. So double equal to, and you may give any data type, any of the other numeric types. Okay, smaller than double is the float. Next one is the float. You go by the range, right? What is the range for double? It's much higher than the range for float. Float is higher than the range for long. Fine. And fine, long is higher than the range for int. Fine. Below int, one side is the short and other side would be char. And you know, both are 16-bit, but ranges are different. They cannot accommodate each other. Okay, and below short would be the byte. Okay, so remember this hierarchy for the primitives, numeric types. Fine. Other than this, there's only Boolean, right? That remains outside this. Okay, fine. So Boolean is not a numeric type, so it's not in anywhere in this hierarchy anywhere. It's a separate type. And so assignment wise, now you can understand which can be assigned to what. And so this is to be remembered, right? This should be okay. Now let's come back and discuss the reference types now. Okay, and let's begin with the array type. Okay, or one of the classes, maybe there's one specific class, a very special case. Okay, among the reference types, there is one class, special class, and that class is called, I'll give the name of the class here. Okay. So we have a class, I think I'll put it in text, start putting in text. Okay, I'll make a. It's fine. Then this should be clear. Fine. Okay, so that's what we do, right? Okay. Now, among the reference type, yes, another important thing about the reference type, there is a special class which is the super type for all reference types. Right? So if you declare a variable of type object, obj, let's say, equal to, I can use any reference type. It might be an array, you can assign it. Okay, you can assign a int array, string array, any kind of array also. You have an interface type, can be assigned to object. It's a super type for all the reference types. So object though falls in the category of class but is special in that it is the super type for all the reference types. Right? So any reference type is assignable here, and fine. So that's one class to know. Okay, now let's start dealing with the array type. What is an array type? We understand this now. I think all of you know what is an array type. Collection, it's a collection of, or even sequence, sequence of a particular data. So multiple elements, fine, for a particular data type. Okay. So in Java, arrays are fixed size. Fine. An array object. So one thing, what that object being a super type? So every reference type is an object. So we are talking about, when I'm saying object, I'll also use the term an array object. Right? So arrays are objects. That's how you should look at them. Okay. Fixed number of elements. And an array object will have a fixed number of elements. Okay. Okay. Now, how they differ from C? Some similarity and some notation-wise, a few similarities, and but lot of differences as far as the declaration is concerned. Yeah. How do we declare a array type in C? Let's say in C. How do we have an array? How do we create an array rather? Int array, int a, like this, right? Oh, you'll have to specify the size. That's how you do it. That's in C language. Okay. Okay. To achieve an equivalent thing in Java, okay, I might have to say something like this. Okay, you want to keep some similarity from C, and so okay, fine. I'll also put it the other way around. Which we find is more logical. Okay, so both the statements are equivalent. In Java, both the Java statements are both equivalent. Right. So we declare a variable A. The second one, if you look at that second one, the type is array of int. Okay, and what is that new int 5? Create an object. Because just the A itself is not an object. A was never an object. Okay, so first part is a declaration part. Second part, assigning to what? Some object. Okay, so here saying, okay, allocate an object of 5 integer elements. Allocate an object of array with 5 integer elements. Okay, fine. Now, how do you find out how many elements are there in A? Given an array, okay, maybe I have a method, for example. Oh, we had used it already. So if variable A refers to an array of int or whatever, right? Of int, A dot, yeah, how do we know that? Yes. because we have used this while taking the command line arguments. Dot length. Yeah, a dot length is a fine. So length here, arrays are like this. Okay, so okay, fine. So now because they are reference types, there's no question of okay. The one thing, arrays have fixed length. Once an array object is there, it has a fixed length. Right? So a dot length, will it always be 5? No.
One question.
Yeah.
In some references,
Yeah.
it has been seen that when you declare an array, if you don't have in mind like this would be the particular size, you can like declare a with a blank square bracket, and then you can assign particular type numbers of
Yeah.
data.
So you can do it in two parts, right? Okay.
So in
Okay.
that case,
Let's look at the two parts of this. So this could have been done in two statements. One could have been, right? Yeah. Declare a variable, not put a value. And here is, okay, this is allocate an array. Okay.
No,
So two parts of it. Yeah.
yes.
Now, yeah. Okay.
Yes, complete.
And then we have a equals new int 7. Here system.out.println a dot length. Yeah. Okay. Same way you can repeat this here. Yeah. So what happens in between? What will this print? 5. What will this print? 7. What happens to the earlier array? There were two objects now. There is only one variable, but we have two objects. The first object, which was with 5 elements, was initially there referred from A. Later you said, okay, I'm not going to refer to this, let me refer to something else. The assignment here for a reference variable changes reference to an object. Now I'll be referring to a different object. That's what assignment is. Assignment for a reference type is, okay, I want to refer to a different object than whatever I am referring now. Okay. So we have friends. So we got, that's it. Oh, sorry. Okay. So we have A here, okay, where it is declared as of type int array. Okay, fine. And then we are saying equals, we say new int 5. So what's happening? Oh, we have an object. This object has 5 integers. This object has got 5 integers. And A equal to, A refer to this. New means object creation. A refer to this. Equal to means refer. Change reference. When assignment is about changing the reference. Okay, fine. Whenever we allocate using new, fine, whatever gets allocated will be zeros. Numeric type is zeros. If it's a Boolean type, what is getting allocated? it's going to be false. And default values for numerics is 0 and default value for Boolean is false. Okay, so maybe it was int array or sometimes it might be a Boolean array. What you get will be all false, but that's because you used new. Okay, oh, when we are saying a equals new int 5, this is what happened. And when we said a equals new int 7, what happened? Oh, new int 7, so it has to allocate. Right? It allocated an array with 7 elements, and it stopped referring here and started referring here. Change the reference. Clear? Reference, meaning of referencing. Right? Clear? So from C++, how different it is. C++, if I say string s equals hello, s is the string. Right? Okay. Fine. And the object is, when the variable itself is the object. Here, variable is a reference to the object. Right? See, in C++, we have something called pointer. If it's a pointer type, if a variable is a pointer type, then we use the operator like this, right? In C++, we use this. If it's a pointer type, then we can use this to refer to the element within the object. Here, instead of this, we have to use dot. Okay. Thanks. Okay, so all reference type, you can say, oh, they are references. And so that should be clear. Okay, fine. Now let's proceed with the array itself. Fine, there are more things to be seen in the array itself. So reference as a type should be clear again. And then, okay, so this is one thing. Now let's try something more. Okay, okay, we can have a equals, then what? Okay, now you can't you had that option. Okay, let me now do a new variable. Let me have a int array. Fine. I normally prefer using type separately, array type along with the b, right? Equals. It could have been b here and array afterwards. And but this is what is more logical, right? Because that's a type and that's my variable of this type. Fine. So array is a type, and we say this variable is of a particular type of array. Okay, equals, and you can do this also, right? Yeah. Right? If I say b dot length 4.
I was referring to this kind of example.
Yeah.
Here,
So yeah, this is an object. Okay, fine. Now, if I want to do now here, okay, coming back to this place, if I want to do a similar thing here, a equals, it's going to be invalid. Okay, whatever it is, right? Maybe this is not going to work. Okay. Okay, whereas I can do like this. New int array and then write this. and that's working. So if you want to use a constant, right, the type needs to be indicated, okay, because the type is not on the left hand side. Here the type is on the left hand side. Type is known from the left hand side, okay, fine, and therefore you can do. Otherwise, if the type is not known from the left hand side, you'll have to indicate with the declaration. So we can call this as an array constant, array literals, and braces, that's used for array literals. Okay. Okay, now we understand references, therefore let's make another thing here. So this is fine, A and B is like this is okay. Okay, if I say A equals B now, what happens? Let's follow this whole sequence. If I say A equals B, which one is updated? A is updated. A will be referring to 1, 2, 3, 5. Both are, so we have multiple references, two variables referring to the same object. Okay, we can have more than one variables still referring to the same object, right? After this, if I say A of 5, oh, there won't be 5. There are only 4 elements, so we can have 0 to 3. Okay, A of 2, or if someone says B of 2, it would mean the same. Because it's the same array. We are referencing through A or through B. Give me the element at index position 2 from the array A. When you say A square bracket something, you're asking for from this object referred from A, give me the second element. So AB, A of 2 and B of 2 are referring to the same object. A and B refer to the same object. So this gives me the same element. Yeah. So it's not like, oh, I have got so many variables of type array and therefore I have got so many arrays. No, they are not necessarily different arrays. Fine. Okay. Fine. So this is single dimensional array. Fine. Okay. Fine. We understand use of arrays. We know referring to the array and putting an value into the array. So I can say A of 2 equals 5, and then if I look at what is system dot out dot println B of 2, it would give me 5. Yeah. Okay. So you update from one, it's available in the other because it's the same element. Okay. So we can like, so this is single dimensional array. Okay. Right. Okay. So before going to the two-dimensional array, let's have array of a reference type. Okay. Fine. Example, what's a reference type? String. Let's take string as a reference type. String is name of a class. Okay. Fine. So it's a reference type. Classes are reference type. So string is a reference type. So if someone says string s, I think I need not repeat that part. Okay. Now, so having an array of a string. Okay. So if I say string array s array, let me make it equals And because I'm putting in the same line, I'm using the constant. Two elements. Right? S array dot length 2. Okay, fine. Then okay. Okay, now how does it look like? If now can I okay, what is of 0? What is happening? Yeah. Okay. What is the type of S array 0? String. Fine, right hand side is a string, so this is valid. Okay. I think let's look at the figure now. Okay. So I'm saying string array, and let's say if I have a string array. Okay, let me do it not exactly with the same example as what we have done. Okay, let me use a different example here. Suppose I say string array s is equal to, okay, and let's use the keyword new. Okay, and let's to specify the type of the array to allocate string, and if I say 5, yeah, what happens in this case? We have a s is a reference to an array. How many elements in the array? 5. What are the type of each of those 5 things? String. So it's a reference type. What is allocated? These are 5 references. They are not objects. These are 5 references. Initially, they are null. Default for reference type would be null, not referring to any object. Okay. If I make s of 0 is equal to, okay, it would mean we have an object which has the value high. This is a string array, string object, and s of 0 would refer to this. Clear? Array for a reference type means refer to an array. It's a array of references. And it would contain the elements are references in this array. They are in turn referring to the other object.
So in an array,
Yeah.
string by default stores 0.
String is what type? Reference type?
Yes, earlier like we said
Numeric type?
0.
0.
Yes.
What is string? Numeric? No.
No.
It's a reference type. Not only string, any reference type. It would be null.
Okay.
But the variables are references, right? What is allocated are references. Okay. What's allocated are references. So these are all nulls. The other ones are all nulls. Right? You can make this also null again. S of 0 equal to null. Okay. It would stop referring to this one. Okay. Right? So yeah, there'll also be a question about, oh, what happens to the objects where we are setting it to null? This becomes free object, right? So there's actually a mechanism in the Java virtual machine to collect objects which may not be, which are not usable. Okay, we'll come to that later maybe, but fine. Let's look at the, now let's go for a two-dimensional array. Fine, array for a reference type. Here it's nothing but an array of references. What is a two-dimensional array now? We don't have something like a two-dimensional array, but rather we have array of array type. Array of an array type. So for example, someone says, okay, let's someone says, oh, I want an array of any type, right? So I can say my type is int array. Okay, that's my type. It's a reference type, and I want an array of that. So many times, yes, we say this is a two-dimensional array, no? It's referred to as two-dimensional array. Okay, right? And we have a variable, let's say here, okay, let me use a variable called a here. Okay, and now equals. Let's look at the, if we use new, how do we allocate, right? If I have to say new and allocate, I have got two options here. I can say new int, okay, and I must specify the two dimensions here. Okay, I'll say, okay, let me have it as a 10. And for the second dimension, I have two options. I can have an option of specifying the value or need not specify the value. You can leave it blank also. Okay, or one option is this, other option is maybe I'll specify the value as 5 here. Okay, so let's look at both the cases. So if I'm just doing it like this initially, okay, where I'm not specified the second dimension, what will happen? Here's a reference A. It's allocating a array with how many elements? And these are the 10 references. It is allocating 10 references here. Okay, fine. Which are, right? I have said 10. So therefore, and what are they? What are they? How are they initialized? Null. But if I had made it as 5 over here, I'm asking it to also allocate the second level. Fine. Allocate 5 elements for each of them. Allocate 5 elements for each of them. So it would be like this. Okay, you refer here, and so on. Fine. The last one also would be getting it. So there'll be similar such things. And at the end, the last one says, okay, you also have those 5 elements. Yeah. Like this. Each one is an int array now. These are the int array where the elements are int. This is type for A, type for A, array of int array, 2 dimensional. Type for A of I, int array. Type of A of ij, int. Int. The element is an int here, right? These elements are int array. And this one, array of int array. Types, I'm just referring to what is the type for A. Right? It's an array of int array. Yeah, array of int array. Fine, clear? Two-dimensional array. Okay, now what would happen? Fine, now, okay, now let me put a small, so if this is understood, I'll just put a small question here. Fine. So I'll continue on that two-dimensional array now. Okay, fine. So I'll take that example over here. Two-dimensional array A equals new int 10 and 5. Okay, fine. So we have allocated both the dimensions, and then what I have done is I've said A of 2 equals A of 0. A of 2 equals A of 0. And then let's write, we understand, okay, now let's write a loop for int I equals 0, I less than A dot length. Okay, this is how we can go over all the elements of the first level. Within that, I'm saying for int j equals 0, j less than A of I dot length. And let me make A of ij, yeah, that's a int equals I plus j, whatever row plus column number. So in each element I'm putting some value, and then the question here is, if I use system.out.println A of 0, 3, what will be the value printed? I'm making everything, if it is ij, it is I plus j, row plus column number. So what should be A of 0, 3? Yeah. What should be the value? Okay, now I'll put it one thing, do not ignore this statement. Do not ignore this statement. Yeah, what should be the answer? 3 I plus j, 0, 3, and therefore you will say 3. The answer is 5. Want to check how it works? Okay. See what's happening here? Okay. First, I is 0. Oh, what's the effect of A2 is equal to A0? What is the effect? A2 is an int array. A0 is an int array. Now, whether I go through A2 of something or A0 of something, it is the same. It's the same object now. Okay, this will be more clear if I show it here. Okay, fine. So 0, 1, this is A0, this is A1, there is a A2. Okay, this was also some object. Anyway, it won't matter what object it is, and there everything is 0 here, right? In the integer values, everything is 0. Okay, now we are saying A2 equals A0. What does it mean? We are updating the A2, right? This element, we are saying, no, you stop referring here. Instead, refer to this only. Now we are saying I equals 0, updating the elements over here, 0, 1, 2, 3, 4. Okay, picking I equals 1 and j 1, 2, 3, 4, 5. Picking I equals 2. Where are we updating? We are updating here only, making it 2, 3, 4, 5, 6. First, initially it was 0, but then in the loop, when it went through that loop second time, with I equals 2, it has updated the same place. Clear the references, how they work. Just to know that yes, they are all references. Fine. Two references refer to the same object. Okay?
Initially the value is 3, but
Yeah.
when the loop runs for A2,
Yeah.
the value gets updated.
When I becomes 2, it's the same place it's updating. And at the end, we are then looking at, oh, what's the value? It was initialized with 3 also, but then it was rewritten with 5. Yeah. So 2-dimensional arrays, like 2-dimensional, we can have 3 and more, right? So it can go right up to 255 dimensions, not more than that. Number of dimensions. Anyway, we don't need so many. Okay. Okay, we will continue tomorrow now.